Okay, this lesson is on solving by square root. So we talked about in the last lesson solving by graphing as well as solving by factoring. You could factor it and then set them equal to 0 and get your solutions. You could graph them and see where they cross. If they're whole number solutions, you could do that. The other way is by square roots, and this is eventually going to lead to quadratic formula because there's square roots in quadratic formula, and that's the next lesson. But in order to solve by square roots, we have to remember how to simplify square roots because we want answers to be in exact radical form, and the only way to do that is to be in square root form, in simplest square root form. So we're going to go back sort of to Algebra 1 here and review our simplifying of square roots. So what you may have learned in simplifying square roots is a tool called the prime factorization tool. What that means is you just break the number down into numbers that go into 72. Now, some teachers just teach you, hey, just keep dividing by 2, dividing by 2, dividing by 2. The problem is that makes your tree very, very long. So my advice is to use use numbers that are not 2. Use higher numbers. Like, for example, 72 is 8 times 9. So using 8 times 9 will generally do the trick. And then you do these. What multiplies to be 8 is 4 and 2, and then 4 is 2 and 2. 9 separates into 3 times 3. Now, the reason why this is called prime factorization is that you end up with all prime numbers at the bottom of these. So here's what you do. Any pairs that you see like this and like this will come out of the radical. So I have a pair of 2's and a pair of 3's, so you do 2 times 3, which is 6. And anything that is left unpaired here will remain inside the radical. So your final answer is 6 radical 2. So we can do that. We'll do another example here. Sometimes there are even numbers out front. So for that, we just sort of leave it. We don't really do anything with that number. We're going to do this. So 52, you have to think of, okay, what multiplies to be 52? It could be, you could do 2 and 26, but we want to maybe avoid that. I know 4 goes into it, so it's actually 4 times 13. And then 4 breaks down into 2 and 2. And 13 is a prime number, so it actually does not break down. So for this particular one, I have one pair and one that's unpaired. So the 2 will come outside, and the 13 will stay on the inside. Now here's where this extra number comes in. Because there was a -3 already, you need to multiply these two numbers on the outside for a final answer of -6 radical 13. And that's how you simplify radicals. So there's one more over here, 64. Hopefully you notice when you have a perfect square, like 64 is a perfect square. You don't need to break it down. I mean, you could break it down, but everything would be paired up. The square root of 64 is just 8. Square root of 36 is 6, and 49 is 7, and 81 is 9. So all those are perfect squares. So that's how you simplify radicals. Now go ahead and try the next 3 there on your own. Pause the video and then hit play when you're ready to see the answers. Okay, there are your answers to the problems. You can go ahead and check the work if you want and see. Now yours might look different. because you may have chosen different factors for yours, but the answers should all be the same. So if you have any questions, please pause the video and you can go ahead and ask me any questions that you have with those. So again, like I said, this is going to lead eventually into the quadratic formula. So when you do the quadratic formula, a lot of times you will end up with an answer that looks like this. So the problem is that is not simplified. So what we need to do is take the radical here. Oh, that's not what I wanted. We need to take the radical here and simplify it. So we can sort of bring this out here. So I have radical 32, which will break down into 4 times 8, which is 2 and 2, which 8 is 4 and 2, and 4 is 2 and 2. So when you simplify this, you have a pair of 2's, another pair of 2's, and then this last 2 that's unpaired. So what I get is 4, because 2 times 2 is 4, and then radical 2. Now that is going to replace the radical 32. So now what I have is 4 plus or minus 4 radical 2 over 8. And now that I have simplified the radical, I can see that each piece here is actually, I can factor something out. They're all divisible by the same number. So I can take this and just say, hey, I'm going to divide everything by 4. Now we ignore what's in the radical 2, when we do this, because radical 2 is not actually 2. We only do what's outside. So since they're all divisible by 4, I'm going to divide everything by 4, and I get x equals 1 plus or minus 1 radical 2 over 2. And that's your answer. Now you don't need the 1 in front of the radical 2 here, but so you could just put radical 2, but just showing you how you get that. So again, let's try another one. So here is another example where if you were doing quadratic formula, you would have this radical here that may not be simplified. So again, you pull it out. So radical 54. 54 is 9 times 6. And 9 is 3 and 3. And 6 is 3 and 2. So I have a pair here. And I have 2 things that are unpaired. So the 3 will come out. The things that are unpaired will stay in, which is a 3 and a 2. So 3 times 2 is 6. This is now going to replace the radical 54. So now I have negative 6 plus or minus 3 radical 6 over 3. Again, I can see that all of these are divisible by 3. We ignore the radical, because remember, the square root of 6 is not actually 6. So we leave the radical alone. So my answer is, if I divide everything by 3, is negative 2 plus or minus 1 radical 6 over 1. Now, just like in the previous problem, we don't need the 1 here or the 1 here. So it could just be negative 2 plus or minus radical 6. But either way, there's your answer. And that's that. So go ahead, again, pause the video and try the problem below on your own, and hit play when you're ready to see the answer. Okay, there's the answer. The radical 20 came out and simplified to 2 radical 5, or replaced that. All of the numbers were divisible by 2, so I divide everything by 2 and got 1 plus or minus 1 radical 5 over 2. Like I said, the 1 that's in front of the radical 5 you do not actually need, but I just put it there just so you can see that. Okay. Finally, to what we're actually doing here, and that's solving by square roots. What we just did before is simplifying. We'll need that when we're doing solving by square roots, but we'll also need it when we do quadratic formula. in the next lesson. So solving by square roots. So how do you know when to solve by square roots? Basically, when you solve quadratics, there's really only two ways to solve quadratics effectively, and that is quadratic formula or by square roots. There are a bunch of ways to solve quadratics, but I'll tell you right now the most useful ways to solve quadratics is using quadratic formula or by square roots. And really the only difference is the number of x's that you see. If you notice in all of these problems, there's only one set of x's. So like only one x there. There's no other x's. This is the only x. Same thing here. That's the only x. Same thing here. It's the only x. Same thing here. It's the only x. But if you look at previous, if you look at normal quadratics, they'll have an x squared and an x. So you have multiple x's. What gives it away that you're going to solve by square roots is the number of x's. If there's more than one, you use quadratic formula, and if there's one, you use solving by square roots. The nice thing about solving by square roots is you can solve the problem just like a regular equation. So, I can, add the 7 over, and I get 5x squared equals 125. And then I can divide the 5 over, just like you're solving a regular equation. X squared equals 25. But here's where it changes a little bit. Because I have the square, in order to get rid of this square here, I do have to square root both sides. So I'm going to square root here, that cancels. And you have to remember that any time you take the square root, it is always plus or minus. And in this case, the square root of 25 is plus or minus 5. You will always, unless it's 0, you will always have two answers when taking a square root. So that's solving by square roots. Just solve it like a normal equation. Just square root at the end. And don't forget the plus or minus. Now, the other way that this can look is like this. So here, in this particular type of problem, you're still going to solve for x. I'm still going to subtract the 4 over. Okay. And then I have parentheses x minus 3 squared equals 16. Now, the thing here is what students tend to want to do is they tend to want to distribute this in, and you can't do that. You can't do that. Please don't do that. Okay. You can, just like you did in the previous problem, when you get to a point where you can't move anything else over anymore, you can square root both sides. I know it looks weird, but you can. Okay, that gets rid of the square, so I'm left with x minus 3 equals plus or minus 4. Square root of 16 is 4. Now here it gets a little tricky because when you go to add 3 to the other side, you're actually adding 3 to two different numbers. You're adding 3 to positive 4 and you're adding 3 to negative 4. So you actually get two different solutions. Positive 4 plus 3 is 7. Negative 4 plus 3 is negative 1. So you get two actual answers. So that's solving by square roots. Go ahead and pause the video. Try the problems below on your own, see what you get, and hit play when you're ready to check your answers, and see if you get them right. Okay, here are your answers. The first one over here was a little bit more straightforward. Add the 6 over, 36. You can't do anything else, so you square root both sides. Gets rid of the square, and you get x plus 2 equals plus or minus 6. You then have to subtract the 2 over from positive 6 and from negative 6. So positive 6 minus 2 is 4, and negative 6 minus 2 is negative 8. The second one was a little bit more tricky. As we look at the second one here, a couple things happen. So yes, we do add the 4 over and get 24. Yes, we divide by 3 and get 8. So the problem with 8 is it's not a perfect square, so we can't just make it a number. So it ends up being just plus or minus the square root of 8. But then 8 can be simplified. Divides into 4 and 2, which 4 goes into 2 and 2, which means that you have 2 radical 2. So technically, the answer is plus or minus 2 radical 2. Though, if you did leave it like this, probably it would be okay. But technically, this is the most simplified answer. That's it. That's solving by square roots, simplifying square roots, and solving by square roots. So go ahead and try the practice that's in this module and see how you do. If you have any questions, let me know.